We're talking about the fundamental theorem of algebra, and we want to find all the zeros of the polynomial function. In this case, we have x cubed plus 3x squared plus 16x plus 48. And remember, there's four terms here, so we could try to factor by grouping and it would work. But I just want to reiterate our synthetic substitution and how we do that. And so the way that we find out what we're going to substitute in is we take p divided by q. Remember, p represents all the factors of our constant term, and q represents all the factors of our highest degree, which in this case is 1. So really all we have to do is come up with all the factors of 48. So the factors are going to be plus or minus 48, plus or minus 24, plus or minus 16, plus or minus 12, plus or minus 8, plus or minus 6, plus or minus 4, plus or minus 2, plus or minus 3, plus or minus 2, and plus or minus 1. So those are all of the possible factors. And so we have to pick one of these, or at least one of these, maybe more, will be a factor of the given polynomial. So we can just practice some, plug some in and try it. Remember, we have to have our degrees have to go in descending order. So 3, 2, 1, 0. So that's all set. And then we're going to use our coefficients. So we have 1, 3, 16, and 48. And those are going to be the values that we use. So 1, 3, 16, and 48. And then we're going to divide or synthetic substitute by, I'm going to pick the value of 3. Now I don't know if 3 is going to work. It's just we're going to test it out. So remember, add down, multiply in the diagonal. So 1 plus 0 is 1. 1 times 3 is 3. Add down 6. Multiply across 18. Add down 34. Multiply on the diagonal 102. Add down 150. All right. So this means that positive 3 is not a 0. So we'll repeat the process. We'll try a different one. This time I'm going to try negative 3. Again, if it's just trial and error. We can use a graph to help us out if we have that capability, but if not, we just have to go with what we can work with. Use the same coefficients. And then we're going to add down and multiply on the diagonal. And so we get 1. 1 times negative 3 is negative 3. 3 plus negative 3 is 0. 0 is multiplied by negative 3 is 0. Add down, we get 16. And then we get negative 48. And then that gives us 0. All right. So that tells us that negative 3 is a 0. Now, that gives us the remainder of our polynomial. So our remainder was 0. Then we have our constant term, our linear term, and our x squared. So what I'm going to do now is I'm going to rewrite the factored form of this polynomial here. So negative 3, the factored form of that, or the binomial that would give us negative 3, is going to be x plus 3. And now I'm going to write down the remaining polynomial here. So I'm going to multiply that by the leading coefficient on the x squared term is 1, so that's going to be x squared. There is no linear term because 0 times x is 0. And then we have a constant term of 16. All right, now we can use the zero product property that we've used many times, and we can come up with, just to check this first one here, so x plus 3 equals 0. How do you solve that? We subtract 3, and we get x is equal to negative 3. We already knew that was a 0, but that's just how we check that. The next one, we want to solve x squared plus 16 is equal to 0. So we subtract 16 from both sides, and we get x squared equals negative 16. Then we take the square root of both sides. Anytime we take the square root when we solve, that makes plus or minus the square root of negative 16. Our square root cancels our square. Now we have a negative under the radical, and we can simplify this as x equals plus or minus. We know the square root of 16. We can write that as the square root of 16 times the square root of negative 1. The square root of 16 is 4, and the square root of negative 1 is equal to I. So the degree of this polynomial is 3, and we have one real root here at x equals negative 3, and then we have two imaginary roots, one at x equals plus 4i and one equals negative 4i. So our solutions for this one are x equals negative 3, 4i, and negative 4i. Those are the three zeros for this polynomial. If we look at the graph, we can see that we have the graph typed in over here, and we have 1, 0 at negative 3, 0, which we calculated, and we don't have any other spot where it crosses the x-axis. That is because our other two roots of the 3 are imaginary,